and Cassandra. So knowing these databases is also very important. So next one is data visualization, which is I think one of the most important skill sets which are required. So as an analytics professional, you should know how to visualize the data in order to, basically improve your business. So you need to know what kind of trends are going to be there in the data and how it is increasing and what kind of insights this data is going to provide you. So you should be able to visualize the data. You should be able to understand what the data is indicating. The next one is specific business knowledge. So this is extremely necessary according to me, because if you're an analytics professional and you don't know what business your company is basically working on and you're not aware about it, you won't be able to apply your knowledge of analytics to basically increase the sales and marketing of the company. All right, so the business knowledge of a particular company or the area which you're working on is extremely important. The last skill set that I've mentioned over here is computational frameworks. So out of the tools that we discussed in the previous section, one is expected to know at least more than one. So if you know Apache Spark, Hadoop, Pig, also again, that is depending upon the job role that you're going to play. So it is important that you're aware about at least one or more tools which are, required for big data analytics, and one or two such computational frameworks, because it is going to, of course, help you, and you will have a basic knowledge about how these tools are used for analyzing the data.
Let us start with the U.S. primary election use case first. In this use case, we will be discussing about the 2016 primary elections. In the primary elections, the contenders from each party compete against each other to represent his or her own political party in the final elections. There are two major political parties in the U.S., the Democrats and Republicans. From the Democrats, the contenders were Hillary Clinton and Bernie Sanders, and out of them, Hillary Clinton won the primary elections. And from the Republicans, the contenders were Donald Trump, Ted Cruz, and a few others. As you already know, Donald Trump was the winner from the Republicans. So now, let us assume that you are an analyst already, and you have been hired by Donald Trump, and he tells you that I want to know what were the different reasons because of which Hillary Clinton won. And I want to carry out my upcoming campaigns based on that so I can win the favor of the people that voted for her. So that was the entire agenda. So this is the task that has been given to you as a data analyst. So what is the first thing that you will need to do? The first thing you'll do is that you'll ask for data, and you have got two data sets with you. So let us take a look at what this data set contains. So this is our first data set, which is the U.S. primary election data set. So these are the different fields present in our data set. So the first field is state. So we've got the list of the state of Alabama. The state abbreviation for Alabama is AL. We've got the different counties in Alabama like Artuga, Baldwin, Barber, Bibb, Blount, Bullock, Butler, etc. And then we've got FIPS. Now, FIPS are Federal Information Processing Standards Code. So this basically means zip code. Then we've got the party, so which we will be analyzing the Democrats only because we want to know what was the reason for Hillary Clinton's win. So we will be analyzing the Democrats only. And then we've got the candidate, and since I told you there were two candidates, Bernie Sanders and Hillary Clinton, so we've got the name of the candidate here and the number of the votes each candidate got. So Bernie Sanders got 544 in Artuga County, and Hillary Clinton got 2387. And this field over here represents the fraction of the votes, so if you add these two together, you will get a 1. So this basically represents the percentage of vote each of the candidates got. So let's take a look at our second data set now. So this data set is the U.S. County Demographic Features data set. So the first we will have, again, FIPS in the area name, Artuga County, Baldwin, and different other counties in Alabama and other states also. The state abbreviation, so here it is only showing Alabama, and the fields that you see here are actually the different features. You won't know what this exactly contains because it is written in a coded form, but let me give you an example what this data set contains. Let me tell you that I'm just showing you a few rows of the data set. This is not the entire data set. So this contains different fields like population in 2014 and 2010, the sex ratio, how many females, males, and then based on some ethnicity, how many Asians, how many Hispanic, how many Black American people, how many Black African people, and then there is also based on the age groups, how many infants, how many senior citizens, how many adults. So there are a lot of fields in our data set, and this will help us to analyze and actually find out what led to the winning of Hillary Clinton. So now you have seen our data set. You have to understand your data set. You have to figure out what are the different features or what are the different columns that you are going to use. And you have to think of a strategy or think of how you're going to carry out this analysis. So this is the entire solution strategy. So the first thing you will do is that you need a data set, and you've got two data sets with you. The second thing that you'll need to do is to store that data into HDFS. Now, HDFS is Hadoop Distributed File System, so you need to store the data. The next step is to process that data using Spark components, and we will be using Spark SQL, Spark mlib, etc. So the next task is to transform that data using Spark SQL. Transforming here means filtering out the data and the rows and columns that you might need in order to implement or in order to process this. The next step is clustering this data using Spark mlib, and for clustering our data we will be using k-means, and the final step is to visualize the result using Zeppelin. Now, visualizing this data is also very important because without the visualization you won't be able to identify what were the major reasons, and you won't be able to gain proper insights from your data. Now, don't be scared if you're not familiar with terms like Spark, SQL, Spark mlib, k-means, clustering. You will be learning all of these in today's session. So this is our entire strategy. This is what we're going to do today. This is how we're going to implement this use case and find out why Hillary Clinton won. So now let me give you a visualization of the results. So I'll just show the analysis that I have performed and I'll show you how it looks. So this is Zeppelin, which is in my master node in my Hadoop cluster, and this is where we're going to visualize our data. So there's a lot of code. Don't be scared. This is just Scala code with Spark SQL, and at the end you will be learning how to write this code. So I'm just jumping onto the visualization part. So this is the first visualization that we have got, and we've analyzed it according to different ethnicities of people. For example, in our x-axis we have foreign-born persons, and in the y-axis we're seeing that among the foreign-born people, what is the popularity of Hillary Clinton among the Asians. And the circles represent the highest values. The bigger circle is the bigger counts. So we have made a few more visualizations. So now we've got a line graph that compares the votes of Hillary Clinton and Bernie Sanders together. Again, we have got an area graph also that compares Bernie Sanders and Hillary Clinton votes, and hence we have a lot more visualization. We have got our bar charts and everything finally. We also have state and county-wise distribution of the votes. So these are the visualizations that will help you derive a conclusion to derive an answer, whatever answer that Donald Trump wants from you. And don't worry, you'll be learning how to do that. I'll explain each and every detail of how I've made these visualizations. So let's get started with Hadoop and Spark. We will start with an introduction to Hadoop and Spark. So now let's take a look at what is Hadoop and what is Spark. So Hadoop is a framework where you can store large clusters of data in a distributed manner and then process them parallelly. Then Hadoop has got two components for storage. It has HDFS, which stands for Hadoop Distributed File System, and it allows to dump any kind of data across the Hadoop cluster, and it'll be stored in a distributed manner in commodity hardware for processing. You've got Yarn, which stands for Yet Another Resource Negotiator, and this is the processing unit of Hadoop, which allows parallel processing of the distributed data across your Hadoop cluster in HDFS. Then we've got Spark. So Apache Spark is one of the most popular projects by Apache, and this is an open source cluster computing framework for real-time processing, where on the other hand, Hadoop is used for batch processing. Spark is used for real-time processing, because with Spark, the processing happens in memory, and it provides you with an interface for programming entire clusters with implicit data parallelism and fault tolerance. So what is data parallelism? Data parallelism is a form of parallelization across multiple processes in parallel computing environments. A lot of parallel words in that sentence. So let me tell you simply that it basically means distributing your data across nodes which operate on the data parallel, and it works on fault-tolerant systems like HDFS and S3, and it is built on top of Yarn, because with Yarn you can combine different tools like Apache Spark for better processing of your data. And if you see the topology of Hadoop and Spark, both of them have the same topology, which is a master-slave topology. So in Hadoop, if you consider in terms of HDFS, the master node is known as the name node, and the working node or the slave nodes are known as data node. And in Spark, the master is known as master and slave are known as workers. So these are basically daemons. So this is a brief introduction to Hadoop and Spark, and now let's take a look at Spark complementing Hadoop. There's always been a debate about what to choose, Hadoop or Spark, but let me tell you that there is a stubborn misconception that Apache Spark is an alternative to Hadoop, and that is likely to bring an end to the era for Hadoop. It is very difficult to say Hadoop versus Spark because the two framers are not mutually exclusive, but they are better when they are paired with each other. So let's see the different challenges that we address when we are using Spark and Hadoop together. You can see the first point that Spark processes data 100 times faster than MapReduce. So it gives us the results faster and it performs faster analytics. The next point is Spark applications can run on Yarn leveraging Hadoop cluster, and you know that Hadoop cluster is usually set up on commodity hardware, so we are getting better processing, but we are using very low cost hardware. And this will help us cut our cost a lot, so hence also the cheap cost optimization. The third point is that Apache Spark can use HDFS as storage, so you don't need a different storage space for Apache Spark. It can operate on HDFS itself, so you don't have to copy the same file again. And if you want to process it with Spark, so hence you can avoid duplication of files. So Hadoop forms a very strong foundation for any of the future big data initiatives, and Spark is one of those big data initiatives. It's got enhanced features like in memory processing, machine learning capabilities, and you can use it with Hadoop. And Hadoop uses commodity hardware, which can give you better processing with minimum cost. These are the benefits that you get when you combine Spark and Hadoop together in order to analyze big data. Let's see some of the big data use cases. So the first big data use case is web e-tailing. The recommendation engines, whenever you go out on Amazon or any other online shopping site in order to buy something, you will see some recommended items popping below your screen or to the side of your screen. And that is all generated using big data analytics and ad targeting. If you go to Facebook, you see a lot of different items asking you to buy them. And then you got search quality, abuse, and click fraud detection. You can use big data analytics and telecommunications also in order to find out the customer churn prevention, the network performance optimization, analyzing network to predict failure, and you can prevent loss before the error or before the fault actually occurs. It's also widely used by governments for fraud detection and cybersecurity in order to introduce different welfare schemes. Justice, it has been widely used by healthcare and life sciences for health information exchange, gene sequencing, serialization, healthcare service quality improvements, and drug safety. Now let me tell you that with big data analytics, it has been very easy in order to diagnose a particular disease and find out the cure also. So these are some more big data use cases. It is also used in banks and financial services for modeling true risk, fraud detection, credit card scoring, analysis, and many more. It can be used in retail, transportation services, hotels, and food delivery services. And actually, every field you name, no matter whatever business you have, if you're able to use big data efficiently, your company will grow and you will be gaining different insights by using big data analytics and hence improve your business even more. Nowadays, everyone is using big data, and you've seen different fields, and everything is different from each other, but everyone is using big data analytics, and big data analysis can be done with tools like Hadoop and Spark, etc. So this is why big data analytics is very much in demand today and why it is very important for you to learn how to perform big data analytics with tools like this. So now let's take a look at a big data use solution architecture as a whole. You're dealing with big data now. The first thing that you need to do is you need to dump all that data into HDFS and store it in a distributed way. And the next thing is to process that data so that you can gain insights. And we'll be using Yarn because Yarn can allow us to integrate different tools together, which will help us to process the big data. So these are the tools that you can integrate with Yarn. You can choose either Apache Hive, Apache Spark, MapReduce, Apache Kafka in order to analyze big data. And Apache Spark is one of the most popular and most widely used tools with Yarn in order to process big data. So this is an entire solution as a whole. Now, so let's take a look at Apache Spark. Apache Spark is an open source cluster computing framework for real-time processing, and it has been the thriving open source community and is the most active Apache project at this moment. And Spark components are what make Apache Spark fast and reliable. And a lot of Spark components were built to resolve the issues that cropped up while using Hadoop MapReduce. So Apache Spark has got the following components. It's got the Spark core engine. Now, the core engine is for the entire Spark frameworks. Every component is based on and it is placed in the core engine. So at first, we've got Spark SQL. So Spark SQL is a Spark module for structured data processing, and you can run a modified Hive queries on existing Hadoop deployments. And then we've got Spark Streaming. Now, Spark Streaming is the component of Spark which is used to process real-time streaming data and is a useful addition to the core Spark API because it enables Hive throughput and fault tolerance, stream processing of live data streams. And then we've got Spark MLib. This is the machine learning library for Spark, and we'll be using Spark MLib to implement machine learning in our use cases too. And then we've got GraphX, which is the graph computation engine, and this is the Spot API for graphs and graph parallel computation. It has got a set of fundamental operators like subgraph, join purchases, etc. Then you've got Spark R. So this is the package for R language to enable our users to leverage Spark power from R shell. So the people who have already been working on R are comfortable with it, and they can use R shell directly at the same time, and they can use Spark using this particular component, which is Spark R. You can write all your code in the R shell, and Spark will process it for you. Now let's take a deeper look at a realistic people and all these important components. So we've got Spark Core, and Spark Core is the basic engine for large-scale parallel and distributed data processing. The core is the distributed execution engine, and Java, Scala, and Python APIs offer a platform for distributed EDL development, and further additional libraries which are built on top of the core allow for diverse streaming, SQL, and machine learning. It's also responsible for scheduling, distributing, and monitoring jobs in a cluster, and also interacting with storage systems. Let's take a look at the Spark architecture. So Apache Spark has a well-defined and layered architecture where all the Spark components and layers are loosely coupled and integrated with various extensions and libraries. First, let's talk about the driver program. This is the Spark driver, which contains the driver program and Spark context. This is the central point and entry point of the Spark shell, and the driver program runs the main function of the application, and this is the place where Spark context is created. Well, what is Spark context? Spark context represents the connection to the entire Spark cluster, and it can be used to create resilient distributed data sets, accumulators, and broadcast variables on that cluster. And you should know that only one Spark context may be active per Java virtual machine, and you must stop any active Spark context before creating a new one. Let's talk about the driver program that runs on the master knob of the Spark cluster. It schedules the job execution and negotiates with the cluster manager. This is the cluster manager over here, and the cluster manager is an external service that is responsible for acquiring resources on that Spark cluster and allocating them to a Spark job. Then in the worker node, we have got the executors. The executor is a distributed agent that is responsible for the execution of tasks, and every Spark application has its own executor process. Executors usually run for their entire lifetime of the Spark application, and this phenomenon is also known as static allocation of executors, but you can also opt for dynamic locations of executors where you can add or remove Spark executors dynamically to match with the overall workflow. Okay? So now let me tell you what actually happens when the Spark job is submitted. When a client submits a Spark user application code, the driver implicitly converts the code containing transformations and actions into a logical directed acyclic graph, or DAG, and at this stage the driver program also performs certain kinds of optimizations like pipelining transformations and then converts the logical DAG into a physical execution of a plan with a set of stages, and after creating a physical execution plan, it creates more physical execution units that are referred to as tasks under each stage, and these tasks are bundled to be sent to the Spark cluster. So the driver program then talks to the cluster manager and negotiates for resources, and the cluster manager then launches the executors on the worker nodes on behalf of the driver. And at this point, the driver sends tasks to the cluster manager based on the day replacement, and before the executors begin execution, they first register themselves with the driver program so that the driver has got a holistic view of all the executors. Now, the executors will execute the various tasks that are assigned to them by the driver program, and at any point in time when the Spark application is running, the driver program will keep on monitoring the set of executors that are running the Spark application code. And this driver program here also schedules future tasks based on data replacement by tracking the location of the cache data. So I hope you have understood the architecture of Spark. Any doubts? All right, no doubts. Now let's take a look at Spark SQL and its architecture. So Spark SQL is the new module in Spark, and it integrates relational processing with Spark's functional programming API, and it supports querying of data either via SQL or via Hive query language. So for those of you who have been familiar with RDBMS, so Spark SQL will be a very easy transition from your earlier tools because you can extend the boundaries of traditional relational data processing with Spark SQL, and it also provides support for various data sources and makes it possible to read SQL queries with code transformation, and that is why Spark SQL has become a very powerful tool. This is the architecture of Spark SQL. So let's talk about each of these components one by one. First, we have got the data source API. So this is the universal API for loading and storing structured data, and it is built on support for Hive, Avro, JSON, JDBC, CVS, Parquet, etc. So it also supports the third-party integration through Spark packages. Then you've got the data frame API. Data frame API is the distributive collection of data that is organized into named columns and is similar to relational table in SQL that is used for storing data in tables. So it is the domain-specific language applicable to, or DSL applicable on structured and semi-structured data. So it processes data from kilobytes to petabytes on a single node cluster to a multi-node cluster, and it provides different APIs for Python, Java, Scala, and R programming. So I hope you have understood all the architecture of Spark SQL. We will be using Spark SQL in order to solve our use cases. So these are the different commands to start the Spark daemons. These are very similar to Hadoop commands to start the HDFS daemons. So you can see to start all the Spark daemons, so the Spark daemons are master and worker, and you can use this command to check if all the daemons are running on your machine. You can use JPS like Hadoop, and then in order to start the Spark shell, you can use this. And you could go ahead and try this out. So this is very similar to the Hadoop part that I just showed you earlier, so I'm not going to do it again. And then we've seen Apache Spark also. So now let's take a look at k-means and Zeppelin. K-means is the clustering method, and Zeppelin is what we're going to use in order to visualize our data. So let's talk about the k-mean clustering now. K-means is one of the most simplest unsupervised learning algorithms that solves the well-known clustering problem. So the procedure of k-means follows a simple and easy way to classify a data set to a certain number of clusters, which is fixed prior to performing the clustering method. So the main idea is define k-centroids, one for each cluster, and the centroids should be placed in a very cunning way because of different location causes different results. So here, let's take an example. So let's say that we want to cluster a total population of a certain location, and so we want to cluster them into 4 different clusters, namely group 1, 2, and 3, and 4. So the main thing that we should keep in mind is that the objects in group 1 should be as similar as possible, but there should be as much difference between an object in group 1 and group 2. It means that the points that are lying in the same group should have similar characteristics. And it should be different from the points that are lying in a different cluster, and the attributes of the objects are allowed to determine which object should be grouped together. For example, let us take in the same sample that we're using in the U.S. county. So let's consider the second data set we have used. There are a lot of features that I already told you, like there are age groups, and they are categorized by professions, and they also categorized by the ethnicity. And so this is the thing that we are talking about. So these are the attributes that will allow us to cluster our data. So this is k-means clustering. Here is one more example. Let us consider a comparison on income and balance. So in my x-axis, I've got the gross monthly income, and in the y-axis, I have the current balance. I want to cluster my data according to these two attributes. Here, if you see, this is my first cluster, and this is my second cluster. So this is the cluster that indicates the people who have high income and low balance in the account, and they spent a lot. And this cluster comprises of the people who have got a low income but a high balance, and they are safe. You can see that all the points that are lying here have got similar characteristics, that they have got low income and high balance. And here are the people who share the same characteristics, where they have got low balance and high income. And there are a few outliers here and there, but they don't form a cluster. So this is an example of k-means clustering, and we'll be using that in order to solve our problems. So does anybody have any questions? So here is one more example and one more problem for you. So you guys will tell me now. So the problem is that I want to set up schools in my city, and these are the points which indicate where each student lives. So my question to you is, where should I be building my school if I have students living around the city in these particular locations? And in order to find that out, we will do k-means clustering, and we'll find out the center point, right? So if you can cluster and make groups of all these locations and set up schools at the center point of each cluster, that would be optimum, isn't it? Because that is how the students have to travel less. It will be close to everyone's house. And there it is. So we have formed three clusters. So you can see the brown dots are one cluster, and the blue dots are one cluster, and the red dots are one cluster. And we have set up schools in the center points of each cluster. So here is one, and here is yet another one. So this is where I need to set my schools up so that my students do not have to travel that much. So that was all about k-means, and now let's talk about Apache Zeppelin. This is a web page notebook which brings in data ingestion, data exploration, visualization, sharing, and collaboration features to Hadoop and Spark. So remember, when I showed you my Zeppelin notebook, you can see that we have written the code there. We have even run SQL codes there, and we have more visualizations by executing code there. So this is how interactive Zeppelin is, and it supports many, many interpreters, and it is a very powerful visualization tool that can use, that goes very well with Linux systems, and it supports a lot of language interpreters. It supports R, Python, and a lot of other interpreters. So now let's move on to the solution of the use case. So this is what you've been waiting for. First, we will solve our U.S. county solution. So the first thing we will do is we will store the data into HDFS, and then we will analyze the data by using Scala, Spark SQL, and Spark ML Lib. And then finally, we'll find out the results and visualize them using Zeppelin. So this was the entire U.S. election solution strategy that I told you. And I don't think I should repeat it again, but if you want me, I can. Should I repeat? All right, so most of the people are saying no, so I will go right through this one again. So let me just go to my VM and execute this for you. So this is my Zeppelin, and I open my notebook here, and let us go to my U.S. election notebook, and this is the code. So first of all, what I'm going to do is that I am importing certain packages because I'll be using certain functions that are in those packages. So I've imported Spark SQL packages, and I have also imported Spark ML Lib packages because I'll be using k-means clustering. So Vector Assembler enables me certain machine learning functions. So over here, I have the Vector Assembler package that gives me certain machine learning functions that I'm going to use. I've also imported the k-means package because I'll be using k-means clustering. Then the first thing that you need to do is that you need to start the SQL context. So I've started my Spark SQL context here, and the next thing that you need to do is that you need to define a schema, because when you want to dump our data set or we want to dump our data, it should be in a particular format, and we have to tell Spark in which format it should be. So we're defining a schema here. So let me take you through the code. So I'm storing schema in a variable called schema, and we have to define the schema in a proper structure. So we're going to start with struct type, and since you know that our data set has got different fields as columns, we're going to define this as an array of fields. And then this is an array and struct, so we are defining the different fields now. So we'll start with the first field by defining it as struct field inside the braces, which should mention what should be the name of that particular field. So I've named it as state. It should be a string type, and true, that means it is a string type. The next we've got fips, which is of string type. Now I know that fips is a number, but since we are not going to do any kind of numeric operation on fips, we're going to let it stay as a string. Then we've got party as a string type, candidate as a string type, and then votes as integer type, because we're going to count the number of votes, and there's going to be certain numeric operations that we are going to perform that will help us to analyze our data. Then we've got a fraction votes, which you know is a decimal type, so we have to keep it as double type. The next thing you need to do is that Spark needs to read the data set from the HDFS. So for that, you have to use the command spark read, option header true. Header true means that you have mentioned and you have told Spark that my data set already contains column headers, because state as ABBR, they are nothing, but they are column headers. So you don't have to explicitly define the column headers for it. Neither will Spark choose any random row as a column header. So it will choose only the column headers your data set has. Then you have to mention the schema that you have defined. So I have defined it in my variable schema. So that's why I have mentioned it in my file. It should be in CSV format. And then I have mentioned the path of the file in my HDFS. This is the path, and I stored this entire data set in my variable df. Now what I am going to do is that I'm going to divide up certain rows from my data set, because you know that my data set contains both the Republican and Democrat data, and I just want the Democrat data, right? Because we're going to analyze the Hillary Clinton and Bernie Sanders part. Okay, so this is how you divide your data set. So the first thing that we have done is that we have created one more variable called DFR, and we have applied a filter where party is equal to Republican. And then we are storing the Democrat Party data into DFD. So we're going to use the DF_D from onwards, and DFR, the Republican data, is going to be your assignment for the next class. Now, I am going to analyze the Democrat data, and then after this class is over, I want you guys to take the Republican data. This data set is already available in your elements, and you've got the VMs, also with everything installed. So please, when you are at home, when you have free time, just analyze the Republican data and tell me what were the reasons that Donald Trump won. I want you to do all that analysis and come up with that in the next class, and we'll discuss about it and whatever results and conclusions that you have made after analyzing the Republican data. And that way you'll also learn even more, and it will also be practice for you after today's class. So all right, so we are going to take df_d now, and the first thing that we will do is that we will create a table view, and I'm going to name the table view as election. And let me just show you what it looks like and what it has. So this is the command that I have run in Zeppelin. So this is SQL code that I have run in Zeppelin. And you can see that I have got states, state_ABBR, and I have only got the Democrat data. All right, now let's go back. All right, so after creating the table view, now all of the Democrat data is in my election table. So now what I'm going to do is that I'm creating a temporary variable, and I'm running Spark SQL code. So what I'm actually doing by writing this code, the motive of writing this SQL code or the SQL query is that I want to refine my data even more. So what I'm trying to analyze here is how a particular candidate actually won. I don't have to do anything with the losing data, because you know that each of FIPS contain one of the losing candidate members and one of the winning candidate members. It contains the data of the winning candidate and the losing candidate also, because my data set contains both of the data of Bernie Sanders and Hillary Clinton. In some parts, Bernie Sanders won, and in some counties, Hillary Clinton won. So I just want to find out that who are the winners in a particular county. Okay, so I'm going to refine that data, and for that I'm using this query. So I'm going to select all from election, and then I'm going to perform an inner join with their query. So this is one more query inside this query, and let me tell you what I'm actually doing. So first of all, what we have done is that we have selected FIPS as B. You know that now you have got two entries for each FIPS, so each FIPS actually appears twice in the data set. So I've named it as B, and now we are counting the maximum fraction votes. So you know that in each FIP we have the maximum fraction vote, and then we can find the winner by actually seeing who has got the maximum fraction votes, and then we have named it as A. The maximum fraction votes column is named as A, and we are grouping by FIPS. So now each of my FIPS will be selected, which has a maximum fraction vote, and I have two columns for that, FIPS, which is 1001 and 1001. So the only row will be selected which has the maximum fraction votes. Now I'll have the winner data, and I've named this entire table inside this query as group TT, and then I'm validating it as where election.fips, the main table view.fips should be equal to the B column that we have created in group TT table, and election.fraction votes should be equal to group TT.A. So any doubts on this query and about how I have written this? All right, so now what we're going to do is that whatever data that we've got here, I'm storing that in election 1. Let me just show you what is in election 1 now. So this is my election table only, and you can see that I've got two FIPS, so 1067, 1067. Now let me show you election 1. So there, now I can see that I don't have repetition of FIPS. I have only one entry for FIPS, and that is the row which tells me who won in that county, or in that particular FIP, or in the FIP associated with a particular county. And you can see for Bullock it was Hillary Clinton, for Cahoon it was Hillary Clinton, Cherokee also Hillary Clinton, and then State House District 19 is Bernie Sanders. So Alaska is mainly Bernie Sanders. So this is what we've done now, and then you can see that we have also got additional columns as B and A. So A tells you the maximum fraction votes, and B tells you the FIPS. So the data in FIPS and the data in B are the same, and data in fraction votes and data in A is the same, right? What I'm going to do now is, since my columns are repeating and they have the same value, I don't want A and B now, right? So what I'm going to do is I'm going to filter out the columns I don't need, and in this case I don't want B and A. And what I'm going to do is I'm going to make a temporary variable again, so I'm using the temporary variable to store some data temporarily. So I'm writing to the Spark SQL code to select only the columns that I want. I want the state abbreviation, county, FIPS, party, candidate, votes, fashion votes from election 1. I'm storing everything in dwinner. I've created this new variable, and whatever there was in temp, I'm assigning it to dwinner. And now I've got only the winner data, so I have got all the counties, and I've got who won in that particular county and by how much in the fraction of the votes. What I'm just doing till now is that I'm just refining our data set so that it will be easy for us to make some conclusions or gain some insights from that data, right? And also let me tell you that it's not always necessary that you are filing your data set in the exact way that I'm doing it. If you have something in mind after you've seen your data and understand your data and you found out what actually you need to do, you can carry out different steps to do that also. This is just one way of doing it, and this is my way of doing it. So I'm just telling you, and then we are creating a table for dwinner, and we are going to name it as Democrat. So let me go again and let me show you what the Democrat table view looks like. You can press Shift Enter. So there you we have column A and B that we had in election 1. And so I've just got the winner data. So now let us go back and find out what we're going to find is that I want to find out that which of the candidates won my state, and then whatever date and whatever result I'll get will be stored in the temporary variable when I'm assigning everything. That will be stored in the temporary variable to a new variable called dstate, and then similarly I'm going to create a table view for dstate, which is state. Let me show you what my state table view actually contains. So there it is. So I've got state, Connecticut, Hillary Clinton won 55 counties, Florida, Hillary Clinton won 58 counties. So this is what we've come up to for our first data set. So now let's see what we can do with our second data set that contains all the different demographic features. First thing, again, you have to define a schema, and this time I'm naming that schema schema 1, since you know that we have got almost 54 columns, so I have to define all those 54 columns also. So you remember what each of those columns contains. So this is exactly what I have done, and I don't need to go through every line, but like I already told you how to define a schema, you can have the code in your LMS so you can take a look at it. So the next thing we're doing, again, we have to read our data set, and I'm storing my data set into a new variable called df1, and this is the path in my HDFS where my data set was. And then I have created a table view for my data set, which is called facts. Now, let me show you what facts contain. As you can see, that it contains abbreviation, state abbreviation, population 2014. So instead of using the code now, or the encoded form that was actually there in my data set, I have given a varied meta name that would describe what it contains, right? So instead of PST 214, I've got population 2014. So does that make sense? Right. It contains all the 54 demographic features or different features that was in my data set. White alone, not Hispanic or Latino, living in the same house, 1 year and over, foreign-born persons, language or other than English spoken at home, high school graduate or higher. So it contains basically all the different features or all the different columns that actually was in my data set and that I have defined in my schema. So this is what facts I have. So now what I'm going to do is that I'm not going to analyze my whole data based on all these different features. I'm going to choose some specific features in order to analyze it. I'm going to take just a few, add one. So these are the different features that I'm going to use. I'm going to use FIPS, I'm going to use state, I'm going to use state abbreviation, then area name, candidate and people who are over 65 years, senior citizens, female people, white alone, black African alone. I'm choosing Asian alone, Hispanic or Latino. So basically what I'm trying to do is I'm trying to check what is the popularity of Hillary Clinton among the foreign people or people from different ethnicities. So I'm choosing white people, black people, and Hispanic people. So I'm just trying to analyze it, okay? And you know that I have stored this in a temporary variable again, and then whatever result I'll get by running this Spark SQL code, I'll store it in a different variable called dfx, and then I'll store it, and then I'll make a table view for df facts such as winner facts. So let me show you what winner facts look like. So it's winner facts. You've got FIPS, the state is Alabama, the state abbreviation is AL for Alabama. The area name is Artuga County. The winner was Hillary Clinton, and the people over 65 years in that particular county is 13.8%. Female percentage is 51.4%. White alone, 77.9%. And so these show you the data. So black, white, or African is 18%, and then I've got the different fields that I have selected. Asian alone, Hispanic or Latino, foreign-born, so I have chosen 14 features to analyze it from. All right? So now what I'm doing again is that I'm going to divide the Hillary Clinton data and the Bernie Sanders data so that we can analyze only why Hillary Clinton won or why Bernie Sanders won in some particular counties. So we are planning to filter the same way we divided Democrats and Republican data from our initial primary result data set. So this is what you have done. So you know that is stored in df facts. So we are putting a filter in df facts where candidate is equal to Hillary Clinton. So that will be stored in HC, and the data of Bernie Sanders will be stored in BS. So after that, what we are doing is that we are doing a one-hot encoding. So we'll add two more columns in our data set, a WBS and WHC. In this case, we are going to do one-hot encoding. And what we're going to do is that we are going to include, or we are going to attach two more columns in winner facts as WHC and WBS. So it'll just contain either 1 or 0. And so you can edit it in that way, whichever county. So if you're considering a county, let's say Artuga County, say if Hillary Clinton is the winner, it will have a 1 in WHC, and in WBS, it will have 0. Similarly, in which counties Bernie Sanders won, so Bernie Sanders will have 1, so WBS will have 1, and WHC will have a 0. And then we are creating different views for both of these two together. So this will only tell me wherever WHC is 1. That means this will only show me the counties where Hillary Clinton won. This will only show me the counties where Bernie Sanders won. And we are creating a view for both of these. So for Bernie Sanders, the view is WBS, and for Hillary Clinton, it's WHC. Then finally, we are merging both of them together using union. So select all from WHC, union all select from WBS, and finally, you have stored it in result, and we have created a table view known as result. So let me show you what this result contains. So there it is for Artuga. It was Hillary Clinton. So we've got the Bernie Sanders data over here at the bottom, and I've got all the different fields also from my second data set, the different features that I chose from my second data set to analyze it. So now comes the actual analyzing part. This is where we are going to perform k-means. But first we have to define the feature columns. Actually, you have to define what is the input that you're going to feed so that you get an output. So this is actually the input that you are going to feed to the machine so that the machine learning goes on, and finally it gives you some kind of result, right? So this is where I'm defining. Again, I'm using an array to define all the different fields from my data sets. I'm using person 65 years and older, female person percentage, white alone or black or African, American alone, Asian alone, Hispanic or Latino, foreign-born persons, language other than English, spoken at home, bachelor degree or higher, veterans, home ownership rate, median household income, persons below poverty level, and population per square mile, WHC and WBS. And then I'm going to use the vector assembler. So this is what enables different machine learning algorithms where we are using k-means. So my input column is features calls. So this is going to be the input, and my output column and will be called features. So whatever result that I'm going to get is features, and we have to transform the results. So this is the final table view that we have created, and you know what transforming means, or transforming again means. So in our strategy, we already saw that we have to transform the data first. So my updated data set was results. So I'm going to transform result and put columns as going to be these, which is feature columns. And output table view will be called features. And then we're going to perform the k-means clustering, and we're going to store it in a variable called k-means. So we're using different functions from Spark library, and we have chosen Spark with clustering k-means. And you know that in k-means we already defined that how many clusters do we need, and we need 4. So we have selected 4 clusters, and then we are going to set feature columns as features. And then set prediction column as predictions. So after that we're going to make a model, and we have defined our input and output columns in rows, so we're going to use keens.fitRow, and whatever predictions we will get we're going to store it in a model, and then we are going to do this, and that we are going to print the cluster centers for each cluster. So let me show you what my cluster centers are. So after we run this code, you can see that these are the different cluster centers. So just what I can make you understand about what we're going to do after k-means clustering and how to analyze it. So the numbers are present. They are placed very haphazardly. So what I have done is that I've picked out each of the cluster center points, and then I have made a new table. Yes, so this is it. So you know that we have 4 clusters. We have got the 0th cluster, 1st cluster, 2nd cluster, and third. So 0, 1, 2, 3. Okay, so 4 clusters, and we have found out this cluster centers according to different features that we fed into my k-means algorithm. So what we observed here in WHC and WBS is that the winning percentage, or the winning chances, of Hillary Clinton was 0.9, whereas winning chances for Bernie Sanders was 0.1. And then if you observe the differences in the cluster centers for each feature, here you can see that there is not much difference, not even here. So it's 50, 49, 49, 51, and then well, again, it is not much of a difference, but if you see here that it's 9 and it's going to 16. So you can do a more detailed analysis on Black or African American. So if you want to know the real support of Black or African American, and you want to see what was their voting pattern, or how popular was Hillary Clinton among them, so maybe this could be a good field to analyze because you see the variations in the number. Similarly, you can check out other features, and you can check out here at 16, 8, 9, and 36. So maybe, again, Hispanic or Latino field, and you should do some more analysis on it. And even here you can see in veterans there's 47,806, whereas we've got 182,000 all. So there is also a lot of difference. And here is only 2,759, and we've got in the 10,000s, we've got numbers, and even 100,000s here. So this is how we can identify that, which are the fields or which we can find the main reasons of the main points where you should make your analysis. So let's go back to our Zeppelin notebook, and here it is. So now what we're going to do is that we're going to visualize the result first. So we are counting from predictions. So you can see that in cluster 1s, the prediction means prediction contains my cluster. Since you know that I've stored my clusters, my cluster information and prediction, this is my output after k-means. So I've got this many clusters, so this is the count of my counties or a count of different various that lie in my particular cluster. You can see that in cluster 1 I have got 1,917, in cluster 2 I've got 751. So maybe I should pay more attention on analyzing cluster 1, right? So that's why I've selected cluster 1 here, and we're making different predictions. So you can see that in the x-axis I have got foreign-born people, and in y-axis I have chosen language other than English spoken at home. And then we are grouping it by candidate. So you can see the lighter blue is for Bernie Sanders and the more dark blue is for Hillary Clinton. So all this light blue is for Bernie Sanders, and you can see that as the number of foreign people increases, you can only see Hillary Clinton in the scatter plot here. So there might be a few outliers like back here in the sizes defined according to Black or African American alone. So you remember that this was the feature where we find a lot of variations in the numbers, so that's why we grouped it according to that. And you can see the bigger the circle represents, the more Black or African American alone. And that's what the conclusion we can find out from this scatter plot. And we can see that as the number of foreign people increases, the popularity of Hillary Clinton is more in larger groups of foreign people. You can also choose different parameters out of all the different features that you have chosen. So remember that we have also seen the variation in veterans, so let's choose veterans in a y-axis. So let's also change x-axis, and let me just use y alone here. So you can see here that there is the x-axis that has white alone, and this is the veterans. So you can see that Hillary Clinton is popular among veterans, also in a smaller group of veterans. Since we have decided the size in Black or African American alone, so the size also represents some values. She is popular among the African American veterans. And then as you go ahead and as the count increases, you can see actually, since it's a scatter plot and it almost represents that this is a point as the number of people increases, or as the number of white people increases, the votes are equally kind of distributed between Bernie Sanders and Hillary Clinton, because there are a lot of points in this scatter plot over here. And you can go ahead and drag and drop different features, and you can make different visualizations on that. Now what we've done is that we know that there are 1,917 counties in my cluster 1. So I'm going to do is that I'm going to see that among these 1917, how many were in favor for Hillary Clinton and how many were in favor for Bernie Sanders. So in cluster number 1, you can see clearly Hillary Clinton is the winner, and Bernie Sanders only has got 764, whereas she got 1,153. Similarly, in cluster 3, again, Hillary Clinton is the winner with 9 and Bernie Sanders with 1. Then it 2, she's also got 388 and Bernie Sanders was 363. So this was a very close call. And again, in 0, you've got 119 and 30. And then we went ahead and created a line chart also of the word distribution for Hillary Clinton and Bernie Sanders. So in keys, we have selected prediction. The values here are WHC and WBS, the sum that we have got over here. So definitely Bernie Sanders is lagging behind. So even though you don't have that table for you, you can also find it out according to this line chart. So you can see that in cluster 0, even again, Hillary Clinton was ahead of Bernie Sanders. In cluster 2, there was a very neck-to-neck competition, and you can see it in the graph year. So this represents cluster 2, and so you can see you have a neck-to-neck competition. And again, in cluster 3, they have got neck-to-neck competition. So this describes the distribution of votes for Hillary Clinton and Bernie Sanders, and definitely Hillary Clinton knows ahead, and that's why, of course, she won the primary elections. So again, you can go ahead and we have created the same graph. It's only just area graph instead of a line graph. The key here are state and candidates. So I've got states and candidates over here, and the values is counties. Once, if you just hover onto this bar chart, you can see that in Connecticut, Bernie Sanders won 115 counties. In Connecticut, Hillary Clinton won 55 only. So in Florida, Hillary Clinton is 58, and in Florida, Bernie Sanders is 9. And here you can see in the Maine, Bernie Sanders won 462. So Bernie Sanders got a majority of votes for Maine. So you can also classify it state-wise. You can find out which are the states. And as Donald Trump, now you will know that which are the states that you can target, right? So you know that in Maine, a lot of people voted for Bernie Sanders, and maybe Hillary Clinton is not popular. So you can go ahead and lead out. So as Donald Trump's party member, you can just advise him to go in Maine and carry out different campaigns because Hillary Clinton is not so popular there. So maybe it would be a little easier to get votes from the people in Maine. So this is what you can make a conclusion from, and it might not be very accurate, but this will be very close. The thing is that you can make different charts. You can make bar charts, you can make pie charts, so whatever counties won have made in the bar chart. So here it is in a pie chart. It looks better, but it's not maybe as insightful. I just placed it so that I can show you you can make pie charts also. So these are the insights that you can make after analyzing your U.S. county data. And this is what you can tell Donald Trump. These are the different suggestions that you can actually go and tell Donald Trump that she is popular among the foreign people and the people who speak different languages. She is popular among the Hispanic people, and then in Maine, she lost a lot of counties. She almost lost all of the counties in Maine. So these are different insights that you have got, and then you can tell your superior or your employer who has hired you to do that. So this is what you can present, right? So this is for a very beginner's level, and there are some more analytics that you need to do. I just showed you a few options. You can go ahead and try more in the Democrats section also. And you remember that you have to do it for the Republican Party also. Now let me see what you've learned today. So if you have any questions right now, you can just go ahead and ask me. So does anyone have any questions? So now we will move on and find out the solution for the instant cab use case. You remember that we have got the Uber data set, which contains the pickup time and the location by 2 columns, latitude and longitude, and we have also got the license number for a particular Uber driver. And what we have to do is that we have to find the beehive locations. That is the point where we will find the maximum pickups, and then we will also have to find out what is the peak hour of the day. So this was the entire strategy. So we've got the Uber pickup data set, and then we store the data into HDFS. We will transform the data set and make predictions by using k-means clustering on the latitude and longitude and find out the bee point or beehive point. So now let me open my other notebook, the Uber notebook. So again, the first thing that you have to do is copy the Uber data set into your HDFS. Now, we've done that before explaining to you the U.S. county analysis. So again, the code is kind of the same. The first thing is that, again, we are importing some Spark SQL packages and some Spark ML lib packages because we are going to use k-means clustering. And you can see vector assembler here again, Spark ML clustering, k-means, and other Spark SQL packages. So then we have to start our SQL context, and we're doing it the same way. Then the first thing, again, we have to define a schema. So now I don't have many fields. I've got only 4 fields if I remember. So the first field was the date and timestamp that defines the time. So we're defining it as DT. And the next field is the latitude, the longitude, and base. Then I'm going to read my data set. This is the path in my HDFS where my Uber data set is there. So I define schema as schema here. The header is true because, again, my data set contains column headers, and I'm going to store in DF. So feature calls here is going to be latitude and longitude because I'm going to find out the beehive point, the point where I will get my maximum kick up from. So again, I have set the input calls as feature calls and output calls as features. So I'm using the assembler to transform my data set, and then again I'm using k-means, and we use the same elbow method. We found out that we should make 8 clusters for this data set, okay? And then we are selecting the prediction column and the output column as predictions, and then we have printed the cluster centers for each cluster. So definitely whatever result we are going to find, the cluster centers will tell me the exact location. So this cluster centers that we will find after k-means is actually the beehive points. This will be the point where I will find maximum pickups, right? So here I have printed my cluster centers, and this defines the latitude and longitude. And this is going to be my location where I'm going to find the maximum pickups. And I got 8 results like that because I got 8 clusters and defined the 8 centers for different clusters. So this is exactly like the K-school problem that I explained to you in k-means. This is exactly what happens just as we found out the center of each cluster, and that is where we are replacing the school or building, the new school. So similarly, this is going to be my beehive point, and this is where I will place my maximum number of cabs, okay? So we found out the beehive points. The next thing we will need to do is we need to find the peak hours, because I also need to know at what time should I place my cabs in the location. So what we're doing now, we are taking a new variable called Q, and we are selecting hour from the timestamp column, and then the alias name should be hour, and we're getting it from our prediction or from the result that we got after my k-means clustering. So now we are grouping it, and it will have the different hours of the day, and then it will just show me the pickups at the different hours of the day in the location that we found out are the beehive points. And then we're going to count how many pickups we are going to get from that place, right? So we're ordering it by descending. So the smaller pickup count will be the first, and then the larger will be at the bottom. Similarly, again, we are creating a new variable called t, and we're going to do the same thing. So here, what we're doing is we are selecting the time, the hour of the date, the latitude, longitude prediction, and we filter by hour, which is not null. So we're filtering out the null values from here. So now we have created a table view for categories. So let me show you what the categories contain. Okay, let me just go down. So I've done some few operations here. So let's scroll back up and I'll show you. And again, we have created table views for T and Q also, which is again T and Q, all right? And then I have made some visualizations for each. So then we have created a value P where hour is not null. So again, we have filtered out the null hours, and we have created a new view called P. So here is my hours. This is my count, and in the x-axis that show how many pickups were there, and this contains different hours of the day. And then I have grouped it by prediction. So the size is according to the count. So you can see that the bigger the circle means the more pickups. So you can find out the biggest circle, and you know that you can find the biggest circle as you go along the x-axis, because this is where the count increases. So you can find out the biggest circle would be here, and it lies in my 4th cluster. And you can see that there are 8,915 pickups at the 17th hour of the day, which is around 5 p.m. And so you know that the maximum pickups are around 4 o'clock or 5 o'clock, and this lies all in my 4th cluster. And so it means my peak hours are around 4 or 5 o'clock in the evening, right? So this is what insight we have gained, and you can tell Instant Cab CEO that I have found out that your cabs should be ready around 4 or 5 because that's the time when people go home from offices or they're going out for dinner or something. And this is what another table view looks like, which is T. So here we have latitude and longitude, and this is where we are finding the beehive locations. So I have got the distribution in a scatter plot again, and you can see that we have got very dense points over here. It means that these represent the beehive points. So what you can do is that you can just put the US map and scale it according to this scale over here, and then you can exactly find out what is the exact location where you need to put your cabs around the 17th hour or the 16th hour of the day, all right? And you know that we had a lot of rows, but the results are only limited by 10,000 if it's around 10,000 rows. But we obviously had a lot more, and you can check in different clusters. So now we are analyzing cluster 0. So here, if you see this point over here, this lies in cluster 4. And this lies in cluster 5, and this lies in cluster 0, so you can analyze each cluster also. So here I have just laid out the latitude and longitude for my 0th cluster, so you can see here where prediction is equal to 0, and I've selected this from the table view of T. So here you can find out the exact latitude and longitude. And here the latitude is 40.722 and the longitude is negative 73.995. So this is how you can pinpoint location where your cab should be during the peak hours. Again, if you see this distribution, this is just a pie chart that I've created with that tells you what is the count of pickups at each hour of the days, starting from 0 to 23. There are 24 slices in this circle. So you can see that these few slices are the bigger chunks, and this is the 19th hour of the day, which is around 7 o'clock, 6 o'clock, 5 o'clock, 4 o'clock, 3 o'clock, and so on. So you can see the midnight maybe nobody travels, so maybe your cabs could rest, or you don't have to place any more cabs during this part of the day. These are the insights that you gained. So any questions on that? I think after doing the U.S. county election, this was pretty easy to do, and this is also pretty easy to understand, and the results, which were also much more clear, correct?
What is a Hadoop cluster? Before getting started into the Hadoop cluster, let us understand what actually a basic computer cluster is. A cluster basically means that it is a collection. A computer cluster is also a collection of interconnected computers which are capable enough to communicate with each other and work on a given task as a single unit. Similarly, Hadoop cluster is also a collection of commodity hardware which can be computers and servers interconnected with each other and work together as a single unit. Hadoop cluster has a master and numerous number of slaves. Master assigns the task and guides the slaves. Now that we know what a Hadoop cluster is, let us now understand its advantages over the other similar data processing units. Some of the major advantages of Hadoop cluster are: Hadoop cluster is scalable, cost-effective, flexible, fast, and resilient to failure. Let us now discuss each one of them in detail. First, Hadoop cluster is scalable. Hadoop is a beautiful storage platform with unlimited scalability. Compared to RDBMS, Hadoop storage network can be expanded by just adding additional commodity hardware. While RDBMS can't scale and process huge amounts of data, Hadoop on the other hand can run business applications over thousands of computers altogether, processing petabytes of data. Second one, the Hadoop cluster is cost effective. Traditional data storage units had many limitations, and the major limitation was related to the storage. Hadoop clusters overcome it drastically by its distributed storage topology. Hadoop clusters use commodity hardware, and the lack of storage can be handled by just adding additional storage units to the system, and the clusters functions as good as new. The third one is Hadoop clusters are flexible. Flexibility is the major advantage of Hadoop cluster. The Hadoop clusters can process any type of data, irrelevant whether it is structured, semi-structured, or completely unstructured. This enables Hadoop to process multiple types of data directly from social media. The fourth advantage is Hadoop clusters are fast. Hadoop clusters can process petabytes of data within a fraction of a second. This is possible because of the efficient data mapping capabilities of Hadoop. The fourth feature is Hadoop clusters are fast. Hadoop clusters can process petabytes of data within a fraction of a second. This is possible because of the efficient data mapping capabilities of Hadoop. The secret behind high-speed performance is that the data processing tools are always kept available on the service. That is, the data processing tool is available on the same unit where the data needed is stored. The fifth advantage is the data clusters are resilient to failure. The data loss in a Hadoop cluster is a myth. It is practically impossible to lose any data in a Hadoop cluster as it follows the data replication, which acts as a backup storage unit in the case of a node failure. So with this, let us move on to our next topic, which is related to Facebook's Hadoop cluster. Since 2004, from its launch, Facebook is one of the biggest users of Hadoop cluster. It is called as the beefiest Hadoop cluster. It approximately uses 4,000 machines and is capable to process millions of gigabytes together. Facebook has 2.38 billion number of active users. To manage such a huge network, Facebook uses multiple storage frameworks and millions of developers writing MapReduce programs in multiple programming languages. It also uses SQL, which drastically improves the process of search, log processing, recommendation system, starting from data warehousing to the video and image analysis. Facebook is growing day to day by encouraging all possible updates to its cluster. Scuba. With a huge amount of unstructured data coming across each and every day, Facebook slowly realized that it needs a platform to speed up the entire analysis part. This is when the Scuba was developed. Hadoop developers can dive into massive datasets and carry on ad hoc analysis in real time. The second update was Cassandra. The traditional data storage units started lagging behind when Facebook search team discovered an inbox search problem. The developers were facing issues in storing the reverse indices of messages sent and received by the users. The challenge was to develop a new storage solution that could solve the inbox search problem and similar problems in the future. The objective was to develop a distributed storage system dedicated to manage a large amount of structured data across multiple commodity servers without even failing for once. This is when the Cassandra was developed. The next update is Hive. After Yahoo implemented Hadoop for its search engine, Facebook thought about empowering the data scientists so that they could store larger amount of data in the Oracle data warehouse. Hence, Hive came into existence. This tool improved the query capability of Hadoop by using a subset of SQL and soon gained popularity in the world of unstructured data. Today, almost thousands of jobs are run using this system to process a range of applications quickly. Today, Facebook is one of the biggest corporations on earth, thanks to its active 2.5 billion users. Let us have an overview on the Facebook's Hadoop cluster, then let us move on to the architecture of Hadoop cluster. So this is the overview of Facebook's Hadoop cluster, which consists of web servers, ad hoc Hive Hadoop cluster, production Hive Hadoop cluster, and many more. Now that we have gone through a few facts on Facebook's Hadoop cluster, let us move on to the Hadoop architecture, which has the following components. The architecture of Hadoop consists of the following components: HDFS and YARN. Let us now begin with HDFS. HDFS consists of the following components: the name node, secondary name node, and data node. Let us discuss about each one of them in detail. Name node. Name node is responsible for running master daemons. Name node is designed to store the metadata, which means the information about the actual data, or in short, the schema of the data. Name node is the first one to encounter the client's request for data. It then transfers the request to the data nodes, which store the actual data. The name node is responsible for managing the health of all the data nodes. It receives a heartbeat from all the data nodes at a particular interval of time, and it also receives a status update of the task assigned. If any of the data node fails to respond with a heartbeat, then the name node considers the data node to be dead and it reassigns the task to the next data node. The next one is data node. Data nodes are called as the slaves of name node, and they're responsible to store the actual data and also to update the task status and health status to the name node in the form of a heartbeat. Now, the last one is the secondary name node. The secondary name node, as it speaks, is not actually a backup of name node, but it actually acts as a buffer which saves the latest updates to the FS image which are obtained in the intermediate process and finally updates them to the final FS image. Now, let us discuss about YARN. YARN, yet another resource negotiator. YARN consists of the following elements: Node Manager, App Master, and Container. Let us discuss each one of them in detail. Node Manager. Node Manager is a Java utility that runs as a separate process from WebLogic Server. It allows you to perform common operations for a managed server, regardless of its location with respect to the administration server. The second one is App Master. App Master is responsible for negotiating the resources between Resource Manager and Node Manager. And the last one is the Container. The container is actually a collection of reserved amount of resources allocated from the Resource Manager to work with a task assigned by the Node Manager. Now, with this, we shall have a look on the overview of the Hadoop cluster architecture, and followed by that, we shall look into the rack awareness algorithm. So this is the architecture of Hadoop cluster, which consists of racks. Each and every rack consists of a set of computers, and one of the rack consists master. And these racks use core switches to communicate between each other. Now, let us move on to the rack awareness algorithm. The rack awareness algorithm is all about data storage. It says that the first replica of the actual data must be located in the local rack, and the rest of the replicas can be stored on a different remote rack. Let us look onto an example to understand this in a better way. Here I am having a data block on the data node 1, and the data node 1 is available on the rack 1, which happens to be our local rack. Now, according to the rack awareness algorithm, the replica of the data block in data node 1 can be stored in the remote racks, which might be rack 2 or rack 3. As you can see, the replicas have been stored in a remote rack, which is the rack number 2. Now, let us deal with a different block. As you can see, we have a new block in rack number 2, data node 7. This is the local rack for the data block stored in data node 7. Now let us see where the replicas of data node 7 are stored. The replicas of data node 7 are stored into the remote rack, which is rack number 3, and the data block is stored in data node 9 and data node 12. As you can see, now we have a new data block stored in the data node 11, and rack 3 is a local rack for the data block stored in data node 11. Now let us see where the replicas of data node 11 are stored. As you can see, the replica blocks of data node 11 are stored in the remote rack, which is rack number 1, and the data blocks are stored in data node 2 and data node 4. With this, we have finished our theory part. Now let us get into the practical part, where we'll learn to set up a Hadoop cluster with one master and two slaves. So let us begin with our practical session. Here we must create 3 host systems, out of which one is the master and the other 2 are the slaves. So I'll be choosing the Linux operating system for this, and I'll be using CentOS 7. I'll be starting with creating a new virtual machine. Here I'll be selecting my ISO image. This happens to be my ISO image, which has the Hadoop pre-installed. So let the process finish. And using the similar process, you must create 2 new host systems, and you must name them as Hadoop Slave 1 and Slave 2, as I have done here. As you can see, I have my Hadoop master here, and Hadoop Slave 1 and Hadoop Slave 2. Let me start each one of them. Now I have started my Hadoop master, Hadoop Slave 1 and Hadoop Slave 2. Now all the components of Hadoop cluster, which are the Hadoop master, Hadoop Slave 1 and Hadoop Slave 2, all are started. Assuming that you know how to install Hadoop, I have chosen a CentOS operating system which has the Hadoop pre-installed. Now let us start our local host. Our local host is started. Now let us see the HDFS web user interface. This is how our HDFS web user interface looks like. And you can see our name node is in progress. And similarly, let us try to start the HDFS web user interface in our Hadoop Slave 1 and Slave 2. As you can see, the HDFS web user has been successfully started on Hadoop Master, Hadoop Slave 1 and Hadoop Slave 2. Now, let us begin with setting up our Hadoop cluster with Hadoop Master and Hadoop Slave 1 and Slave 2. Before getting started, our first job will be getting to know the IP address of our Hadoop master. To know the IP address of the Hadoop master, we can type in the command fconfig. This command will give us the IP address of our Hadoop master. Here, my IP address is 192.168.233.130. Similarly, let us find out the IP address of our Hadoop slave 1 and slave 2. Now I'm in the slave 1. Here I'll type in my command fconfig, which must show me my IP address of slave 1. So here, the IP address of the slave 1 is 192.168.233.138. Similarly, let us find out the IP address of slave 2. As you can see, the IP address of slave 2 is 192.168.233.129. Now, our next job is to edit the host and set the IP addresses of the master and slaves. Now let us open a new terminal. You can edit the host by the command vi etc/hosts. Here I have already edited the host. As you can see, I have given 192.168.207.134 as my Hadoop master and 192.168.233.128 as my slave 1, and finally 192.168.233.129 as my slave 2. This step must be followed on all the three machines, which is the Hadoop master, Hadoop slave 1 and Hadoop slave 2. Once you define the IP addresses, you can simply press escape and :WQ to exit the terminal and save the changes you made in the terminal. As you can see, I have made the same changes in Hadoop slave 1, and you can also see the same changes in Hadoop slave 2. Remember, you have to follow all these changes in all the three machines, which includes Hadoop master and Hadoop slaves. Now we know that we have defined the IP addresses of all the three machines to all the three machines. Now let us see if they work or not. Let me open a new terminal and try to ping the Hadoop slave 1. The name of my Hadoop slave 1 is slave 1. So let me write ping to slave 1. As you can see, the ping is successful and the data is been sent to the slave 1. Now let me open a new terminal and try to ping to my next slave using the command ping. As you can see, my second slave name is slave 2. So I'll be writing slave 2 and I'll start the ping. As you can see, the ping is successful. Now similarly, let us try this on our slaves too. Let me open a new terminal on slave 1 and let me type in the command to ping the master. As you can see, the name of my master is master. So let us try to ping to the master. The ping is successful and the data has been sent. Similarly, let us try on our slave 2 if slave 2 can successfully send ping to the master or not. Let us open a new terminal and write in ping to the master. As you can see, the data has been successfully sent to the master here. So with this, we have successfully established a Hadoop cluster consisting of Hadoop master and Hadoop slaves. As you can see, the pings are successful. The master is communicating with both slave 1 and slave 2. And similarly, the slave 1 is communicating with master and slave 2 is also communicating with master. Now with this, we have finished our demo session. Now let us learn about managing a Hadoop cluster. Hadoop is both a command line interface as well as an API. It does not require any tool in specific for managing and monitoring utilities. Yet, there are some options available such as Ambari and Hortonworks. The most popular one is the Ambari. Let us see how does a typical Ambari user interface looks like. So this is how a typical Ambari user interface looks like. We can see the HDFS disk usage percentage, data nodes alive, memory usage graph, network usage graph, and CPU loads, cluster load, name node heap, and many more. What is a Hadoop cluster? A cluster is basically a collection. A computer cluster is a collection of computers interconnected to each other over a network. Similarly, a Hadoop cluster is a collection of extraordinary computational systems designed and deployed to store, optimize, and analyze petabytes of big data with astonishing agility. Now that we are clear with the definition of Hadoop cluster, we shall move ahead and understand the factors that decide the Hadoop cluster capacity. The various factors that we need to look into in order to design and deploy an efficient Hadoop cluster are volume of data, data retention, data storage, and the type of workload. We shall discuss each one of them in detail. We shall discuss the first factor, which is the volume of data, and what is its role when it comes to deciding the capacity of a Hadoop cluster. So if you ever wonder how Hadoop came into existence, then it is because of huge volume of big data that the traditional processing systems couldn't handle. Since the introduction of Hadoop, the volume of data is increased exponentially. So it is important for a Hadoop admin to know the volume of data he needs to deal with and accordingly plan, organize, and set up the Hadoop cluster with appropriate number of nodes for efficient data management. Followed by the volume of data, the next factor is data retention. Data retention is all about storing important and valid data. There are many situations where data arrived will be incomplete or invalid that may affect the process of data analysis. So, there is no point in storing such data. Data retention is a process where the user gets to remove outdated, invalid, and unnecessary data from the Hadoop storage in order to save and improve the cluster computation speeds. Followed by data retention, the next important feature is the data storage. Data storage is one of the most crucial factors that come into picture when you are into planning a Hadoop cluster. Data is never stored directly as it is obtained. It undergoes through a process called data compression. Here, the obtained data is encrypted and compressed using various data encryption and data compression algorithms, so that the data security is achieved and the space consumed to save the data is as minimal as possible. Followed by the data storage, the last and the most important factor is the type of workloads. This factor is purely performance oriented. All this factor deals with the performance of the cluster. The workload on the processor can be classified into three types: intensive, normal, and low. Some jobs like data storage will cause low workload on the processor. Jobs like data querying will have an intense workload on both the processor and the storage unit of the cluster. So the type of workloads also matter a lot. So if you want to have a smooth and efficient cluster, then the processors you use and the RAM you use should be high-end. So these were the factors that decide the planning of a Hadoop cluster. Followed by this, we shall move into the next topic, which deals with the hardware requirements of Hadoop cluster. But before that, let us understand the Hadoop architecture. In the Hadoop architecture, we have the following components: the HDFS and YARN. Inside HDFS, we have name node and secondary name node, which are considered as masters. Similarly, in YARN, resource manager would be your master. And when it comes to slaves, data nodes and node managers are the slaves. So basically, name node controls all the data nodes which are existing in a Hadoop cluster. Name node is considered as the master daemon that manages the data nodes. The name node records all the metadata or the schema of all the files which it receives. Followed by that, name node receives a heartbeat and a block report from all the data nodes. On the other hand, data nodes are considered as the slave daemons that run on slave machines. The actual data is stored on data nodes, and the data nodes are responsible for serving read and write requests. So this was the architecture of Hadoop. Now let us discuss about the hardware requirements. The name node, secondary name node, and job tracker are the masters. The name node and secondary name nodes are the most crucial parts of any Hadoop cluster. They are expected to be highly available. The name node and secondary name node servers are dedicated to store all the namespace storage and edit log journaling. So the hardware requirements for these nodes are at least 4 to 6 SAS storage disks. So these disks will be divided as follows. 1 terabyte hard disk space will be dedicated for operating system. Followed by that, 2 terabyte hard disk space will be dedicated for FS image storage. Followed by that, 1 terabyte hard disk memory will be given for other softwares like Apache Zookeeper and other required softwares. Now, when we come into the processor, we require a hexa-core or at least a octa-core processor with 2 to 2.5 GHz processing speed. And now, if we discuss about RAM, we have to include at least 128 GB capacity of RAM for an efficient and flawless performance. And finally, the major part, the internet. One should have at least 10 Gbps speed internet to have an efficient workflow. So these were the requirements for name node, secondary name node, and job tracker, followed by the name node and job tracker. The next crucial components in a Hadoop cluster where the actual data is stored and Hadoop jobs get executed are the data nodes and task trackers, respectively. Let us now discuss the hardware requirements for data node and task trackers. The number of nodes in a standard Hadoop cluster are 24 nodes, and each node should be having a capacity of 4 terabytes storage. Followed by that, the next important requirement is the processor. Similar to the name node, we also need a hexacore or at least an octa-core processor of speeds 2 to 2.5 GHz. Followed by that, the RAM. We should have at least 128 GB of RAM. And finally, the internet should be similar to the name node, that is 10 Gbps. So these were the hardware requirements for the Hadoop cluster. Now let us move ahead and understand the software requirements of the Hadoop cluster. When it comes to software, the operating system becomes the most important one. You can set up your Hadoop cluster using the following operating systems of your choice. Few of the most important and recommended operating systems to set up a Hadoop cluster are Solaris, Ubuntu, Fedora, Red Hat, and CentOS. Now that we have understood the hardware and software requirements of a Hadoop cluster capacity planning, we will now plan a sample Hadoop cluster for better understanding. The following problem is based on the same. Let us assume that we have to deal with minimum of 10 terabytes and assume that there is a gradual growth of data, say 25% every 3 months or every quarter of an year. In future, assuming that the data grows per every year and the data in year 1 is 10,000 terabytes. By the end of 5 years, let us assume that it may grow to 25,000 terabytes. If we assume 25% of year-by-year growth and 10,000 terabytes data per year, then in 5 years the resultant data may be nearly equals to 1 lakh terabytes. How exactly can we estimate the number of data nodes that we might require to tackle this data? The answer is simple, using the formula which is mentioned here. Hadoop storage, HS, is equals to CRS divided by 1 minus I, where C is the compression ratio, R is the replication factor, S is being the size of the data which is being moved into Hadoop, and I is the intermediate factor. Now, let us calculate the number of nodes required. Assuming that we will not be using any sort of data compression here, we shall keep C as a standard 1. And we all know that the standard replication factor in Hadoop is 3. So R is equals to 3. And next, the intermediate factor I is equals to 0.25. Then the calculation for Hadoop in this case will result as follows. HS is equals to 1 into 3 into S whole divided by 1 minus 0.25, which will result in HS is equals to 4S. The expected Hadoop storage instance in this case is 4 times the initial storage. The following formula can be used to estimate the number of data nodes, which is N is equals to Hadoop storage divided by D, which in turn results as CRS divided by 1 minus I whole divided by D, where D is none other than the disk space available for each node. Let us assume that 25 terabytes is the available disk space for single node, each node comprising of 27 disks of 1 terabytes each. Here, 2 terabytes is dedicated to operating system. Also, assuming the initial data to be 5000 terabytes. N is equals to 5000 divided by 25, which results in 200. Hence, we need 200 nodes in this scenario. So that's how we plan a sample Hadoop cluster. Now that we have understood how to plan a sample Hadoop cluster, we shall move into the final topic for today's discussion, which is the Hadoop admin responsibilities. The Hadoop admin should be responsible for implementation and administration of Hadoop administration. Followed by that, he or she should be responsible for testing MapReduce, Hive, Pig, and should be having access for all the Hadoop applications. The third responsibility is the Hadoop admin should be taking responsibility of cluster maintenance tasks like backup, recovery, upgrading, and patching. The fourth responsibility is performance tuning and capacity planning for clusters. The last but the most important responsibility of a Hadoop admin is to monitor Hadoop cluster and deploy security. Who is a Hadoop developer? Hadoop developer is a professional programmer with sophisticated knowledge of Hadoop components and tools. A Hadoop developer basically designs, develops, and deploys Hadoop applications with strong documentation skills. So the basic definition of a Hadoop developer is as follows. A Hadoop developer is a professional programmer who has some sophisticated knowledge about Hadoop components along with its tools. A Hadoop developer basically designs, develops, and deploys Hadoop applications with strong documentation skills. Now, let us move ahead and understand the roadmap to become a Hadoop developer. To become a Hadoop developer, this is the roadmap which you need to follow. Firstly, you need a strong grip on SQL basics and understand the terminology of distributed systems, which is mandatory. Followed by that, the next important skill is that you need to be comfortable with Linux basics. You need to know the important commands and terminologies in Linux. Then comes the next stage where you need to have strong programming skills in popular languages such as Java, Python, JavaScript, Node.js, and many more. Followed by that, you need to have your own Hadoop projects in order to understand the terminology of Hadoop. Then you need to be comfortable with Java because Hadoop was developed using Java. And the most important thing is you need to have a bachelor's or a master's degree in computer science and engineering technology. And finally, you need to have an experience of about 2 to 3 years. You might want to join some startup companies for experience, or you might also want to join some internships based on Hadoop. So this is the roadmap to become a successful Hadoop developer. Followed by this, we shall discuss the skills that are required by a Hadoop developer. Hadoop development involves multiple technologies and programming languages. So the core and important skills to become a successful Hadoop developer are enlisted as follows. Firstly, you need to have a basic knowledge of Hadoop and its ecosystem. Later, you should be able to work with Linux and execute some of the basic commands in Linux. Followed by that, you are expected to have some hands-on experience with Hadoop core components. Then, Hadoop technologies like MapReduce, Pig, Hive, and HBase are mandatory. Followed by that, you should be able to handle multi-threading and concurrency in ecosystem. Once you're familiar with that, your next stage is to work with the ETL tools. The familiarity with ETL tools such as loading data and processing it using Flume and Scoop is compulsory. Followed by that, you should be able to work with backend programming as well. Once you're done with that, you should be experienced with some scripting languages such as BigData, and after that, you should be having a good knowledge of query languages like HiveQL. So these were the few important skills which you require to become a successful Hadoop developer. Now let us move ahead and understand the salary trends of Hadoop developer. Hadoop developer is one of the most highly rewarded profiles in the world of IT industry. Salary estimations based on the most recent updates provided in the social media say the average salary of a Hadoop developer is more than any other professional. Let us discuss the salary trends of a Hadoop developer compared to other technologies. Firstly, VMware. You can see that the salary trends for a VMware professional lies between the $90,000 to $85,000. Followed by that, we have MySQL. So the MySQL professionals also lie under the same segment. Followed by that, we have .NET, VB, which is Visual Basics. Then we have IBM mainframe developers. Then followed by that, we have C++ developers with an annual income of $90,000. Followed by that, we have JavaScript in the same segment. Then SAP developers with a little hike around $95,000 per annum. Then we have Teradata developers. Then we have the second highly paid Unix developers, which lie under the segment of $105,000 per annum. And finally, you can see the Hadoop developers with the most highly paid profile, which lie under the segment of $110,000 paid per annum. Now with this, let us move ahead and discuss the salary trends of Hadoop developer in different countries based on their experience. Firstly, let us consider the United States of America based on experience. You can see that the average salary of a Hadoop developer in United States of America with experience around 1 to 2 years is around $120,000 per annum. Followed by America, we have the average salary of a Hadoop developer in United Kingdom, which comes around £85,000 per annum. And finally, we have the average salary of a Hadoop developer in India, which is around 5 lakh rupees per annum. We shall discuss the salary trends of Hadoop developers in a much detailed way. You can see that in America, For an entry-level Hadoop developers, the salary begins from $75,000 to $80,000. And you can see that for an experienced Hadoop developer, the salary trends from $125,000 to $150,000. Now followed by the United States of America, we have United Kingdom. Here you can see that for an entry-level Hadoop developer, the salary starts from £25,000 to £30,000, and whereas on the other hand, for an experienced Hadoop developer, the salary trends from £80,000 to £90,000 per annum. Now, in India, we have 4 lakh package to 5 lakh package for an entry-level Hadoop developer. On the other hand, for an experienced level Hadoop developer, the salary trends from 45 lakhs to 50 lakhs per annum. Now we shall move ahead and discuss the job trends for a Hadoop developer. You can see that compared to other developers, Hadoop developers has seen a gradual growth in the rate of requirement. The number of Hadoop jobs has increased at a sharp rate from 2014 to 2019. It has risen almost double in between April 2016 to April 2019. 50,000 vacancies related to big data are currently available in business sectors of India. India contributes to 12% of Hadoop developer jobs in the worldwide market. The number of offshore jobs in India is likely to increase at a rapid pace due to outsourcing. Almost all big MNC companies in India are offering handsome salaries